Hi guys, we will be performing the test for sulfate and sulfite ions. So as you can see, we have a solution which is colorless for sulfate and sulfite. So the first step is to add barium chloride. So when we add barium chloride into the test tube containing sulfate, we have the formation of a white precipitate. This can be seen clearly here, the white precipitate. When I shake it, you have the white precipitate all around in the tube. Now we add barium chloride to the sulfite solution. So in sulfite solution, on addition of barium chloride, we also have formation of a white precipitate, which can be seen here. So now the next step to test for sulfate and sulfite is to add hydrochloric acid in these tubes. So we add hydrochloric acid in the tube to which we added barium chloride in the beginning, and you can see that the precipitate remains, it does not dissolve. Here you can see the white precipitate in the tube containing sulfate. Now we add HCl to the tube containing sulphite, and you can see that the precipitate has decreased in its concentration, which means the precipitate would dissolve on addition of excess HCl. So this precipitate has dissolved, and we can see that our solution is now sort of colorless because there is a slight precipitate remaining. This will also dissolve when I add more HCl. So there is another test that can ascertain which ion, sulfate or sulfite, is present. What we would do is we would add acidified potassium manganate that I've taken out in this beaker. When we add potassium manganate in the tube containing the sulfate ion, you can see that the purple color of potassium manganate remains. But when I add it to the tube containing the solution of sulfite ion, the purple color, look at the intensity of purple color. The purple color is lesser in this tube because there was sulfite in it, which will be oxidized to sulfate. So in order to see the reaction more clearly, let's add more sulfite to the same tube. Look at the color fading away. Look at the color fading away. This is because sulfite is being oxidized to sulfate. See, the concentration of the color has decreased because we have the sulfite being converted into sulfate. So KMnO4 is being reduced to Mn2 positive ions. So the color is changing from purple to colorless. If I add more sulfite ion, this color would disappear. Okay, so in order to see this, now I'm adding more sulfite to this tube, and you can see that the color has disappeared. The color turned light purple because I added KMnO4 in excess, but now since sulfite is in excess, the purple color discharges and a colorless solution remains. So what has happened is that the sulfite has converted to sulfate, and in order to test whether sulfate is present in this tube or not, I will re-add barium chloride, because barium chloride forms a white precipitate with sulfate ions. So on addition of barium chloride, as you can see, a white precipitate has formed in the tube that had sulfate in it, and this white precipitate now will not dissolve in HCl, unlike sulfates where it dissolved. So now on addition of HCl, I've added lots of HCl here. As you can see, the precipitate remains, and if I shake the tube is containing a white solution, which is a solution of a sulfate, not a sulfite. So now by doing these extensive tests, we have confirmed the difference between sulfates and sulfites. So as a recap, sulfates and sulfites both form a white precipitate with barium ions, whether it is barium chloride or barium nitrate. followed by addition of, if we have used barium chloride, hydrochloric acid, and if we have used barium nitrate, then HNO3. But the precipitate in sulfate will not dissolve compared to the precipitate in sulfite, which will dissolve. So this is the first difference between these two ions. And the next difference is when we add KMNO4, the purple color does not discharge in sulfates, but it does discharge in sulfites because sulfite ions are oxidized to sulfate. Then we test for sulfates again in the tube containing sulfite by adding barium chloride. We get a white precipitate forming, and then we add HCl, and that white precipitate does not dissolve. So these are the confirmatory tests for sulfates and sulfites.